I visited Sam's offices and lab at Columbia University in New York City. So, please tell me your name and the name of your job.
My name is Sam Sternberg, and I'm an assistant professor at Columbia University.
So, what do you do here?
I teach, and I run a research laboratory, and we do research. So we spend all of our day doing experiments, mixing chemicals, growing bacteria, and also using a tool called CRISPR to edit DNA.
So what is CRISPR and why is it so important?
Do you know what CRISPR stands for? No? So CRISPR stands for clustered, regularly interspaced, short, palindromic repeats.
So
Super complicated.
Repeats of DNA?
Repeats of DNA, exactly. So you know what DNA is?
Yes.
It's a building block of life. It's instructions that make you you and make me me, make the bacteria bacteria. So we found CRISPR in bacteria, but it's also now being used as a really powerful technology for genetic engineering.
So what is genetic engineering?
So genetic engineering is a collection of techniques to kind of change the DNA information in a cell to maybe make bacteria useful for different purposes, or treat disease in different ways, or create different kinds of plants and animals. So we have a lot of different things we can do with genetic engineering.
So what's a typical day at your job like?
Not sitting down and getting interviewed by people like you, I'll tell you that.
Sam showed me around his lab and told me about the different kinds of experiments and research that he and his team work on.
A lot of what we do here, have you ever heard of E. coli? No? E. coli is a bacterium. Do you know what bacteria are?
Yes.
So they're all over your skin, they're in your eyeballs, they're all around your mouth, they're also in your stomach. And E. coli is actually a very common bacteria that grows in your stomach and your intestines, but we also use it in the lab. These are called Petri dishes. What do you notice on there? Little bumps. You know what those are?
Bacteria?
Those are bacteria. Those are called colonies. So the really cool thing is each one, when it first started growing, you take a look at it, started as a single cell that was microscopic. You would never be able to see with your naked eye. But we pop that into here, and you can actually, if you reach your hand inside, you feel it's kind of warm. Same temperature as that little machine over there. It grows at the same temperature as your body.
That smells weird.
And it also smells bad. So you stick this in, and you come back the next day, and what used to be invisible are now all these thousands of little colonies.
So I heard you wrote a book called Crack in Creation. What is it about?
CRISPR and genetic engineering and the science behind those, but also some of the ways that I and my co-author think it could affect society.
So what's your favorite part of the book?
That it's done. It's cool when you work really hard at something that you think no one cares about, and then one day it turns out to be actually really important. So it's really a fun time right now because we have this kind of new discovery that no one else in the world knows about, and we get to be the first people to kind of unfold it and understand exactly how it works and try to build it into something really exciting here. Yeah.
Sam told me a lot of his research involves growing bacteria, so I asked him about how that whole process starts. Where do you get the first cell to start the entire thing?
We have, let's go take a little walk. I'll show you where we start. So you asked about how do we get those first cells, right? Now we're gonna go to super cold. That's hundreds of degrees below zero.
That's crazy.
So this, we put E. coli in here. So here, we also have special gloves to protect ourselves, but I'll just reach
Water
in.
vapor's pouring out. Oh my god.
So these are all racks and racks and boxes and tubes. Yep. So don't touch the metal, but you can play with the snow if you want. So in this box, chemically competent NEB turbo. These are a particular kind of strain of E. coli, the one we just looked at. So we can actually take out a tube. Let me hold on to that. Hold it. So this is maybe 1 million cells of E. coli.
And then you can make that 1 billion too.
So we're gonna go put this on a petri dish together right now.
I saw that Sam grew his bacteria in a petri dish, and I knew that the dish had to stay clean and sterile. So when I saw him taking the cover off the petri dish, I had an important question for him. How do you know that when you're taking this off so you can put that bacteria in, that the bacteria from the air doesn't get inside?
I'm ready to hire him. That's the exact right question.
Sam explained to me that they use special antibiotics that kill all the bacteria that might try to get into the petri dish, except for the one they're trying to grow. Then Sam asked me if I wanted to try growing bacteria. Of course I did. I was so excited.
So let's put your name, E. coli, and then today's date. I always put today's date on.
How do you spell E. coli?
E period, and then new word, COLI.
Sam showed me how to use a pipette to take out the bacteria we had gotten from the super cold freezer.
Perfect. And now we're gonna spit it right into the middle right there. Wonderful.
Sam told me that when it comes to studying CRISPR, the first step is always growing bacteria. Once you've grown the bacteria, then you can pick cells and extract DNA.
Go ahead and throw this out. So nice and slow going to the bottom and nice and slow release of your thumb.
I also learned that CRISPR is basically the find and replace of DNA. Sometimes there's mistakes in the DNA that might make people sick. CRISPR is a tool that can erase those mistakes and replace them with healthy DNA. Pretty amazing!
Great. All right, and now we get to do the fun thing, using those beads. So, because the way that we get these nicely spread out is we want that liquid to be equally well distributed all around the inside. So these are sterile. So we're going to take a little bit of these and just dump them onto the plate.
And you shake it?
And you just shake it. And that's going to spread that liquid all the way around.
Sam and I made 2 separate cultures with different amounts or dilutions of bacteria. One was 1 to 50 dilution, and the second was 1 to 2500 dilution. I wondered how different they might look after they had had a chance to grow.
Since you might not be back here tomorrow, I'm going to send you a picture tomorrow of the result of this experiment. And we're going to hopefully have a bunch of bacteria grow and get all those little tiny circles, those bumps, and then I'll send your dad a picture tomorrow, and you can see if your experiment was successful.
So if I wanted to grow up and do what you're doing, what should I be doing now?
Probably like tomorrow morning, 8 a.m. Can you be in the lab?
I can...
I'll hire you starting tomorrow, and we just get you in the lab, effective immediately.
I'll miss school.
They'll be fine with it. Come on. Yeah, I think work hard. I mean, I worked hard in school. Read about things that excite you. I think what's fun about science is that you can think about the questions that interest you and just go and figure out a place to pursue those questions and answer them. So I think keep on exploring and looking for opportunities to do the things that make you happy.
So would you rather have the superpower of invisibility or flight?
Is that on your list or? That's a really interesting question. I think I would probably say flight. Even though invisibility would be amazing, but I mean, if I could just jump out the window right now and go flying down to my house, my apartment, or southern Manhattan, I don't care about being invisible. Yeah, so definitely flight.
Thank you for spending time.
Thank you. Do I get a handshake?
Hi, it's 24 hours later, and I'm really excited to check out what happened with my experiment. Let's check out this email from Sam. Hi Bailey, your experiment worked. See attached images. Wow. This is the one that had less of the liquid. This is the one that had more, and as you can see, it's way, way more colonies. There's so many. That's pretty cool. If you are here in the lab today, we could pick the colonies and grow them overnight in a liquid culture to extract DNA tomorrow. Good job, Bailey. Well done. Best, Sam. I had a really good time at the lab. Thanks, Sam. See you next time on Bailey Wonders. Bye.